Okay, hello everyone. Welcome to this talk about domain-driven design. What is domain-driven design? Let's talk about that. But first, let me introduce myself a bit. My name is Stefan Koopmanschap. I've been a software developer with PHP for over 25 years now. I started back at the end of the 90s with PHP 3. How many, let's do a raise of hands. How many of you have actually worked at PHP 3? How many of you still think back fondly about those times?
Yeah, right.
Yeah. No, I mean, to be fair, PHP 3 was fun. It was a lot of fun because it was my first real programming language, aside from QBasic. But if I look at where PHP is right now, as opposed to back then, right now is the better place to be. So over the years, I've also worked with the domain-driven design in several different projects, several different variations of domain-driven design. And that's, at some point I was like, okay, this is actually pretty cool, but there is so much in domain-driven design, and as a developer we focus a lot about how do we apply this to our code base. But there is a part that we always forget, and that is the part that I'm going to be talking to you about today. So not a lot of code, but actually the more important part. Oh yeah, guess who am I in this picture? Does anyone want to guess?
The girl in front.
Nope. Nope. I'm this one. That was me back in the very early days when I was not doing anything with software development yet. So, anyway, let's talk about domain-driven design, or DDD for short. It's been becoming more popular in recent years. It's been around for a while now, but in the past couple of years, especially in the PHP world, I've seen it pop up a lot more. At some point, there was even a domain-driven design conference. I think it's still there, somewhere in Belgium every year. And I come into a lot of companies as an external contractor. I come into the company and I think, okay, let's see what they're doing here. So I encounter a lot of different projects, and some do DDD and others don't do DDD. And the fun thing is that there are so many different ways of using domain-driven design. So it's always a bit interesting to see how do they do it here. And during the preparations, I found out that actually doing it is maybe even easier than explaining what it's about, and also determining what do I want to talk about. And as I mentioned, I'm not going to talk a lot about code because the code part is usually something that you can easily find. There's tons of examples online and things like that. But there's another part that is very important that a lot of developers either ignore or forget about or don't even read about because it's not about the code. And that's what I want to talk about. It's very important to realize that domain-driven design is not about software development. It's not called domain-driven development. It's domain-driven design. It is about understanding what you want to build before you build it. And that's why I was really happy with the keynote this morning. Everyone was at the keynote this morning, right? When she was talking about connection. Because that is actually what domain-driven design is about. It is about connection between a developer and the people that are going to use it, and the organization that is going to use the software, things like that. And of course, some of the concepts of domain-driven design will actually be, you can see that in your code, and you will be using a lot of that while you are developing. But it starts already before you start developing. That's when you need to understand, okay, what is this about? So let's first look a bit about where does DDD actually come from. It was first introduced by Eric Evans. Eric Evans wrote this book, the Blue Book, it is called these days. The official title is Domain-Driven Design, Tackling Complexity in the Heart of Software. So yes, it is related to software, but it's not related specifically to development. And that was not actually the start of domain-driven design. It's more that Eric Evans was the first one to actually put it into a book. And people thinking, okay, this is quite nice. He'd been working on very big, complex software projects for a long, long time, and he'd seen a lot of different ways of working, dealing with the complexity. And at some point he was like, okay, I'm going to put this down into a book. And that's where it started, or at least that's where people started talking about, okay, this is actually a pretty cool thing. But a lot of people were, they started reading the book and they were like, okay, but this is very dry reading. It's very hard to actually read this software. And how can I then, after reading this, apply this in my projects? And there was one person that said, okay, I'm actually going to do something about it, and that was Von Vernon. He wrote the Red Book. And the Blue Book and the Red Book together these days are basically seen as the basis of domain-driven design. This one is a bit more practical. It's called Implementing Domain-Driven Design. And actually, I tried reading the Blue Book. I actually read the Red Book. And I would recommend, if you want to read up on domain-driven design, get this one first and start reading this one, because it's a bit more practical. And then, if you have the money and the opportunity, get the Blue Book as well, more as a reference. Because there is a lot of stuff in here that references the Blue Book, where you want to sometimes have the Blue Book to see, okay, where does this come from? What was the original thought about this? So the combination of these two is fantastic. These days there's also a Green Book, which is also about domain-driven design. I haven't actually read that one. I've seen some mixed responses to that one. Some people think it's a bit confusing, but it's also, I think it's called Domain-Driven Design Distilled, and the distilled part says, well, it's a little less big as these two books. And there's tons of other books, of course, so there's enough reading material about this. So that was the Red Book, yes. Okay. Okay. So, domain-driven design, it comes from complex software. That's what we've now determined. And that means also that if you consider looking at domain-driven design, then you have to realize, okay, so this is something that you usually apply to big, complex software projects. If you're going to build a website for the small store on the corner of the street, then you probably don't need domain-driven design. But even if you don't need full-on domain-driven design, it's still possible to read up on it, because there's a lot of elements there that you can use for any project. It's like Scrum. Scrum also, you don't have to do everything that's in the Scrum book. You can just pick some stuff out of there that's interesting. If the only thing you need is a daily moment to synchronize the team, then you can do the daily stand-up, and you can forget about sprints, and you can forget about refinements and things like that. And it's a similar thing with domain-driven design. You can take specific parts out of those books that you can apply to your project. In the end, look at your organization, your project, and see what you need and use what you need. You don't have to do everything. Now, I started by saying that in essence, domain-driven design is not really about development, about software development, and I want to expand on that a bit more. I've worked in development-related jobs for over 25 years now, and the biggest challenge that I've encountered in all those years has never been the technology. There's always been a solution, a technical solution to any problem that I've seen. Yes, some solutions might be complexer than the actual problem. That happens. But the technology has never been the limiting factor. The limiting factor in a lot of projects has been communication. And this is also why I referenced the keynote from this morning, because that connection is missing in a lot of the projects. Even between different developers in the same team, sometimes people use different words for the same thing. And if you don't understand what you're talking about, you can never build a good solution to the problem. So communication is really important, and I've said it before and I'll say it again forever. Communication is the most important skill for a software developer. Because, of course, you need to understand what you're doing with your code, but you need to understand first what you need to do with your code before you actually start coding. And, well, I already mentioned sometimes different people use different words for the same thing. And this is one of the most important things where domain-driven design comes in. When we think about software, we think about models and views and controllers and services and whatever technical jargon that you can think of. And we sometimes are even very creative in coming up with very fancy names for things that are actually really, really simple. And if you think about an e-commerce project, you can talk about checkout flow, but you can also talk about the payment flow, and you can talk about, well, there's like tons of different words to basically describe the same thing, and that is, I have something that I want to buy and I need to input some information and make a payment. That's basically it. And one thing a lot of software developers have, and I definitely am also guilty of this, is that we also always think that we know the best. We know better than anyone what we should name this. And of course, I name it differently than you do, and you name it differently than you do. But we all think that we know the best, and we should use my word and not his word, or that, yeah. But if we do that, if we start thinking of our own words and our own terms and our own language, then we create a disconnect between us and the rest of the world. So instead of thinking up our own terms, why not use the terms that the user uses? Because then when you're talking to a user, you're talking about the same thing, and you understand each other better. Now this is where domain-driven design comes in, because domain-driven design says before you start working on something, you have to actually determine what you are talking about. In domain-driven design we call that ubiquitous language. And ubiquitous language is basically a sort of a dictionary of, if we talk about this, then we mean this part. And if we talk about this, then we mean this. And if everyone agrees on this terminology, on this dictionary, then we all talk about the same thing. And these same words we can then use in our code. So that even when we're reading our code, we still talk about the same thing. And we keep understanding what we are talking about and what we are actually working on. And another advantage of this is that we as developers start understanding the domain, the problem domain that we are working on better. Because now, instead of, immediately in your head you have a picture of how can we solve this problem, you now first think about what is actually the problem. And then you can start solving it. And I've used the term domain, and the domain is of course also part of domain-driven design. So what is a domain? Because, even DDD has its own ubiquitous language, a set of words that everyone uses. A domain is basically, well, let's start with Eric Evans. Eric Evans said this: a domain is a sphere of knowledge, influence, or activity. The subject area to which the user applies a program is the domain of the software. So basically, you build a bit of software for a user that wants to do something. That is your domain. And of course, you can add more domains or subdomains so to create smaller parts of the bigger part. Because of course, if you, especially when you work on big software projects, complex software projects, then you cannot build everything at once. So you want to split it up a bit to make it easier. The smaller the problem, the easier it is to solve that problem. So you can split that down. So if you have that e-commerce example, then you have the part of the e-commerce that that shows the product, and then you have the shopping cart, which is definitely different from showing the product. And then you have that whole payment flow that we were talking about earlier. That is something different from that cart. It's a different piece of functionality. It's different from showing the product, etc., etc. And so in that way you can split it up a bit more and make it easier to solve each of those problems. So this already adds a bit of structure to your project, and it splits up that big problem into smaller pieces of the problem. But even within a certain domain, you can add a bit more structure by creating what a domain-driven design calls bounded context. And a bounded context is basically a small piece of your subdomain that does a specific thing. So the idea is within a shopping cart you might have the same term for things that are have a slightly different meaning, and within a bounded context a specific term always has exactly the same meaning. So that you make it a bit smaller, a bit easier, and a bit more clear what you were talking about. So I created this. I'm not a graphic designer, okay? You can see that clearly from this, but hopefully this makes it a bit easier. So within that webshop domain, I have two subdomains. One is the products and one is the checkout. And then within the checkout, I created two bounded contexts, and one is the cart and the other is the payment. And if I use a certain term within the cart context, then it always means the same thing, but it might be slightly different from that same term being used in the payment context. Now, when you start building software and you want to start with domain-driven design, I mean, you can make this as complex and as detailed as possible, but I always recommend to start simple. Start with only a couple of domains, maybe a couple of bounded contexts within those domains, because it's easier to split something off into a separate bounded context at a later point than it is to merge stuff back together. So start simple, and as you progress within your project, you can always split it up and make it more detailed. Okay, so if you have a definition of a payment, for instance, within the checkout domain, then you're always talking about the same thing, which in checkout is, in most situations, it doesn't actually talk about the payment itself. Because in the checkout flow, the most important piece of information that you want to know about that payment is, was the payment successful? I really do not care which credit card you used, or if you used a bank Ideal in the Netherlands, or whatever it's called somewhere else, or PayPal, or whatever. For me, as the shop in the checkout flow, the only thing I need to know is, was the payment successful? Because then I can tell you the payment was successful, your order is now done. Or if it failed, then I need to tell you, sorry, your credit card was declined, or whatever, your payment was declined, you need to pay in a different way. However, if we now move to another domain, and that's the domain of the accounting department, there it's very important for them to know about what payment method was used, what amount was paid, which bank were you using, etc., because they need to put that into their accounting software, etc. So even within different bounded contexts or different domains, you can have the same words have completely different meanings. And am I going to cheat? Yes, I'm going to cheat. I'm going to talk a bit about code or databases. You can still use, for instance, the same database table for the payment in the one and the payment in the other, but you'll use different classes in your code. Because again, in the checkout, you don't care about a lot of the data in there. So you don't need to even expose it in your code. You don't need to even expose that information in your code. You don't even want to use that because you don't need it. You only make the information available when you need it. And then in the accounting part, you have a different class for the payment that has more information available because you need it there. And this throws back again to you want to start as simple as possible. You want everything to be as simple as possible, because otherwise you get confused. Okay, so now we've heard about the domain and the bounded context and ubiquitous language and things like that, but how do we determine all of that? There's different techniques of doing that. One thing from the Blue Book that I found really interesting, and I hadn't really thought of before reading that, is the idea of modeling out loud. And the idea, it's like rubber ducking. Is everyone familiar with the term rubber ducking? Not everyone. I see a couple of question marks above heads. So the idea about rubber ducking is basically that if you're stuck on a problem, then of course you can call a colleague and explain to them and they can help you solve the problem. But in most situations, when you explain the problem to your colleague, then you already find the answer yourself because you are talking about it out loud and you think about it, about how do I explain this to my colleague, then you already find the solution yourself. So instead of spending time and money of this colleague, you can just explain it to a rubber duck or an elephant. And you don't spend the time and the money of your colleague. Instead, you just spend the time and the money of your rubber duck. But you probably find the solution already yourself by thinking about it, by speaking about it. And that's also the idea of modeling out loud. It's put a group of people in a room and let them talk to each other about what the process is that you need to build software for. And by them having to explain it to someone else, they start really thinking about, okay, what actually happens here? And how do I explain it to someone else? And if you then listen to them and help them to visualize basically the process that needs to be built in your software, you get a lot more information and better information than when you just ask one person to write down what they need. It's a completely different thing. And you can even repeat that process. So let them do that once, then summarize what they described, and then let them do it another time, because there's bound to be someone that says, well, you said this, but I think it's actually that, and that triggers a whole new discussion, and so you get more information about what you actually need. Another way of doing it is called event storming, and event storming is not really part of domain-driven design itself. It's sort of tightly related. It's a great way, also visually, and also an example of modeling out loud, to visually, with sticky notes on a wall, create an overview of the process that you need to build. And this can be really useful also if you are the first one to solve this problem with software. So, for instance, if you want to replace a paper business process that has always been done on paper, if you want to replace that with software, let people explain what they do with that paper form that they get and how many times they have to stamp it before they pass it on to the next department, etc., etc. That gives a great idea, and the result is a full flow of a lot of events and users, people, and etc. of what happens in that process. And that can be really useful to understand, okay, what do we actually need to build with the software? And then at some point, we need to make a map. And the map is basically, well, it's called a context map, or that's how von Vernon named it. And the idea of the context map is to understand the different parts and how they interact with each other. And von Vernon says, when you start working on your software project, the first map you create is the map of the current situation. You don't immediately start thinking of what are we going to build and where do we want to go, but you start with where are we now. And then once you start changing things, you update the map to always reflect the now. What I found is that it can also be useful to create a map of where do we want to go. Where do we think we want to go? Because you will figure out at some point that where you think you want to go is different from where you actually need to go. But it's still useful to have an idea of this is where we want to go, and because then you can find the road to get there. And as I said, along the road you will find out that this is not where you want to go, you need to go there, but that's okay. We can always change things. So let's create a small context map here. We have the product display, which is where we show our products to our customers. Then we have the shopping cart, and of course, when someone adds a product to the shopping cart, there is a communication there between the display and the shopping cart. So we have an arrow between those. And then once a user has added some stuff to their shopping cart, they click on checkout, and then the shopping cart has to communicate, okay, this needs to be checked out. So there is some communication there. I put an arrow there. Then once the checkout is done and someone has made a payment, then the system needs to communicate to our inventory system. These products were purchased, so they need to be taken out of the inventory so that we cannot sell them again, because otherwise we get in trouble with our customers because we're selling stuff that we don't have anymore. So there's definitely some communication there. But if we start thinking about it a bit more, if a user is in the product page of a product, wouldn't it be useful if they already knew if that product was in stock at that point? So maybe we need to have some communication between the product display and the inventory to check, is this currently in stock? Because otherwise we still get a problem because they think they can buy something and they can't. And if we think about that, we need to do the same thing at the shopping cart, because maybe somewhere in between that product was already purchased by someone else. So we also need to check when you go to the shopping cart, are these products still in stock? Are we sure? And of course we can create a reservation system that would be a different component so that we can reserve things before they are even purchased. Things like that. So you might end up with a lot more lines than you first think of at some point, because you start thinking, okay, maybe there is this option or that, or, you know. So eventually you have a big map. And now you might think, okay, now we're done, because now we have a map, we know where we want to go, now we can start coding, right? Of course we could, but no. Let's take a bit more time to refine stuff. And there is so much in domain-driven design. I'm not going to explain everything to you now because there's not enough time for that. We would probably need a whole conference for that. But I want to talk at least a bit about certain terms that come up a lot that help you understand your processes. Domain events. This is very easy. A domain event is something that happens in your business process. So, for instance, product added to cart. That's an event. Or order confirmation email sent. That's another event. And if you start thinking about events in an event-driven architecture, when you talk code, this is basically a similar thing. You can have those events, you can use the domain events, and you can use them as events in your code base as well. And then have something, an event trigger something else. Then there is the idea of an aggregate, and this is something to really think about, because a lot of developers think very much based on their database, right? So, and that's also, if I look at a lot of frameworks, etc., in their documentation, the first thing they say is, well, you have to define the models, and the models reflect what is in your database, so you need to create a model for this, and a model for that, and a repository for this, and a repository for that. The whole idea about aggregates is basically, don't think about the database, think about the structure of your data as it is in a domain. So, for instance, if you have an order, then the order is the aggregate, because that is the main thing, right? But an order also has order items, which, if you think database, the order items would be in a different table with a relation to the order. The payments could also be somewhere else underneath the order. But an order line does not exist without an order. And a payment does not, well, hopefully it does not exist without an order. So you have a lot more data that doesn't exist without the order. So the order is the aggregate. That's the most important thing that a lot of stuff falls underneath. And then there is the command. And the command triggers an event. So for instance, we already talked about the order created event. Create order would be the command, and then that would trigger an order created event. And there is so many more terms that, and I really don't have the time to go through all of them. So definitely start reading books for that. But that process of modeling, you know, it helps you define and make and understand basically what you are working on. There's more stuff, actors, business processes, external systems that you want to somehow put into this context, things like that. There's so many more things to talk about, to think about, yeah, I cannot mention them all because we don't have the time. One thing is important though. While I was preparing this this talk, we have a company Slack. I was talking about, I was basically saying I want to do this and I want to do that and I want to explain this. And at some point my colleague Jaap said, well, does that mean that software development is just an implementation detail? And basically it is literally that. Because with domain-driven design, all of the thinking is already done. Now you just need to put it into code. But you already know now what you need to put into code. You know how to name things. You know how that process works. So now it's just a matter of writing the code to do that. And I'm not saying that we're now done, after we've done all this, we'll be done with the development in a couple of days. No, of course not. But yeah, it's important to realize that it is like this. I already mentioned a bit more about the databases, and really forget about the database when you start writing, when you start doing domain-driven design. It is all about your data, about your domain. And DDD does not care if you store that into a relational database or a document database or an XML file or wherever. It doesn't really care about that. You first need to think about the data, the concept, the domain, and how you put that into code, how you put that into the database, you don't really care anymore. Yeah, you don't really care. Okay, one more thing that I want to mention that is quite useful as well is value objects. And value objects are things that you don't really need to store those as one field in the database, but you can. And one great example is a moment in time. Because a moment in time already contains multiple elements. It contains a year, a month, a day, an hour, minutes, seconds, and time zone, and etc. It can contain a lot more. But you usually want to display it in the same way. And it's easier if in your code you already define one single way of doing that. So that you don't get 3 different date representations throughout your application. You have one way of doing that. And a similar thing for people's names. My name contains of a first name and a last name. There's a lot of Dutch people that also have an infix between. But there's a lot more things that can be part of a name. For instance, a title, Sir Ian McKellen. I don't have a title, but there's people that have official titles like Sir, you have engineer, etc. There's lots of different things that can be part of the name, and you always want to display it in the same way, handle it in the same way. So put those context, put those things into a value object. That will give you a lot more clarity. How much time do I have?
Oh, you still can go on 10
Yeah?
minutes.
Oh, 10 minutes, okay, great. So, now let's look at this in a bit more practical way. Dive into the code a bit more. To be fair, as I mentioned before, domain-driven design is not about the code. So you can do whatever you want in your code. But what I found is that there are different ways of working with domain objects versus, for instance, if you use an ORM, the ORM object. If you want to do it very purely, then your ORM, whatever you use for whatever type of database you use, that part of the code is completely separated from your domain code. If you want to do it very purely, but that is a lot of transforming from one to the other and back, etc., etc. And that can be a lot of work and add a lot of layers of code that, depending on how big your project is, you don't want to add that. There is another way, and that's called interfaces. You can define basically the domain part of your code. You can define those in interfaces and then implement those interfaces on your whatever ORM you use, the classes for your ORM. So you define the domain, the behavior that you expect for that class in an interface. You type it on the interface. So that's still in the domain or application part of your code. You don't officially directly use the ORM library that you use, but in practice, it's actually just the ORM classes that you use. But since you use the interfaces, you don't see that. And that will really lower the complexity of your software and still implement domain-driven design in your code. I don't know how many people here remember the good old days where the controller part of our application was this long. I definitely did that. And these days we say, well, the controller should be very small and all of that business logic should be put into, a lot of people call them services. Domain-driven design also has a similar concept of a service, which is basically a class with logic in it. The logic is not specifically related to one domain object, but when you need to do something that is related to several different domain objects, so you cannot put it into one specific domain object, then you can create a service and execute that logic there. Now the term service, to me, it doesn't really say a lot. I'm very much used to working, for instance, with Symfony, and Symfony also has the idea of a service, but what is a service? It doesn't say anything. So even when you create services, I personally would say, well, you can call it an order service, but what does the order service do? It doesn't tell me anything. So think about the name that you do. If I create a service specifically for processing an order, then you can call it an order processing service. That already tells me a bit more of what happens inside that class. But what does that service even mean in that name? I could also call it the order processor. It's even more descriptive and it's exactly the same thing. So think about the naming and you know, if you create service classes, don't use that service. It doesn't tell you anything. So now, we mentioned the events earlier, the domain events. We can, now I already mentioned, a lot of software these days, a lot of frameworks, etc., they have a kind of event system built in. Please use that. Please don't create your own event system. Most of the times you can map those events, literally, the domain events, literally into classes that you use with your framework, with your CMS, with whatever software you use, and just trigger those events, and then listen to those events with a piece of code that actually does something after that event is thrown. That makes it a lot easier. And of course, then, if you do that, then one event can be handled by something like the order processor, and the order processor can trigger something else by throwing another event. So you get a full event-driven system, but you still understand what's happening. And that's really useful, because you use the naming that we defined earlier, right? And that makes it a lot easier to understand what's happening, and you can see the flow by looking at the events. There is also sometimes some confusion. How many people here use Doctrine? Yeah, quite a few people. There's a couple of names that are a bit confusing between DDD and systems like Doctrine or other ORMs. For instance, entities is a great example. An entity in Doctrine represents the database table. And I already mentioned earlier that you do not want that relation between your domain and your database, because it's two completely separate things. And the same thing happens with repositories. In Doctrine, a repository is something that you can get data from, but you can also usually use it to store data, things like that. A repository in a DDD context is where you fetch your aggregates from. So you also do not, talking about those orders, you do not have a repository for order lines or a repository for your payment or whatever. You just have the order repository, and you fetch the order from there, and that's your aggregate that contains all the data that you need. So that's important to realize. This is a slightly different thing, even though we use the same name here. Now, there is a lot more to cover about domain-driven design. As I said, much more than we can handle in this talk. And I realize that this can be a bit overwhelming, especially when you're new to domain-driven design. So I would say, if you're interested in this, then get the books, especially the red book. That will help you a lot to get you on the way with domain-driven design. And if you're in your research mode, have a look at other things that are related to DDD, but not specifically DDD. Things such as a hexagonal architecture can really help understand how you should structure your code. And that really supports the DDD approach of separating your code into different layers, including the domain layer. CQRS, event storming, that's a lot of terms that I'm just throwing them out there, and you have to do your own research on that. Oh, do your own research, okay. And, well, as I said before, get that red book, and if you have the opportunity, get the blue book as a reference, because these two books are the basis of DDD, and they will explain you a lot about what is the thought behind domain-driven design. But there's also some really interesting blog posts. For instance, Matthias Nobak, I think he was here yesterday doing a workshop. No, he wasn't? Yeah, he was, yeah.
Workshop, you're right. Yeah.
He published some interesting blog posts on how to do DDD in PHP. There is a book on Leanpub called Domain-Driven Design in PHP, which can be interesting. Well, there's a lot more resources. And the great thing is, I created a URL for that. This links basically to a lot of information about domain-driven design. So if you take a picture of anything I did in this talk, take a picture of this one, because this URL is the URL that's going to help you find a lot of resources about domain-driven design. So that's it. Any questions? Let's go back to the... I have to do them all by... Okay. Almost there. There we go, sorry. Any questions? Yes? What is the difference between a context map and a domain model? So the domain model is a very specific thing, like a very specific concept of within your domain. And the map is actually more of an overview of all these different things that you have and how they work together. So the domain model is very much a detail, where the map is more zoomed out, basically. Any more questions? No? Okay, thank you very much.